Hey everyone, one of my subscribers, Dave at Kectronix, sent me a Flipper Zero experimenter board to review. I've attempted to make my own experimenter board in the past that connects to the Flipper Zero and gives you a breadboard to work with, as you can see here. But the Dolphin board takes experimentation to a whole new level. He also sent me the Dorsal Q433 RT board, which I will not be reviewing in this video. I'll do it in a different video once I've had time to put it together and take a look at what it does. The kit comes with two I2C temperature modules. You have to do a little bit of soldering to connect the header pins. This particular module does not have the pull-up resistors for the I2C protocol. This other module here also needs to be soldered. It has a different pinout, and it does have the internal 10K pull-up resistors. When we look at the Dolphin board in more detail, I'll show you those pull-up pins. It comes with an ultrasonic sensor, two of these NFC tags, the RFID key fob right here, and the NRF 24L01 for doing the mouse jacking and wireless bad USB. Put that over here. This ultrasonic sensor is called the HCSR04. So that's the name of the app you're going to want to use. And I'll show you these jumpers later as we do the 10K pull-up and voltage selection. The ESP8266. This is the D1 Mini. This package looks a little scary, but you only have to solder on one set of header pins. So there's a lot more header pins than it looks like. And this one's already soldered on, so if you want to just start playing with Marauder, and this is an ESP32, you can maybe use that first and play with Marauder. These 10 centimeter DuPont wires are really nice as well. I just ordered another set on Amazon. So this is version 1.3 of the Dolphin. There's a dedicated port for the ultrasonic sensor with echo and trigger. The UART's broken out on the top, along with the 5 volts or 3.3 for the power pin. On my experimenter board, I really struggled with labeling, and this is really nice. You can see how everything is labeled really clearly, so it's really obvious what connects to what. There's a really nice dedicated breadboard area here. So there's 12 combinations for I2C devices. I'll be curious to try plugging in my different devices and see what combinations we have and don't have. The jumpers in the very bottom let you hook up 3.3 or 5 volt, multiple Wi-Fi modules. Then we have the SPI breakout on the right and modules for the NRF 24L01 for the mouse jacking. There are also these connectors on the side, but I don't think I currently own any sensors that use either one of these connection formats. It comes with 4 jumpers. So the first jumper is the UART power, so I put that on 3.3 volts, which is going to make that V plus a 3.3 volt line. Next, it has a jumper for the LEDs, and that'll control the 3.3 and the 5 volt light. So you can see my 5 volts off right now. And then we have a jumper for the 10K pull-up on your I2C. And right now I have that jumper just connected but not across, so that way I'm not using it, but it's there when I need to connect it up. And then I've set my I2C voltage to 3.3 volts as well, instead of 5. So you can see right now I only have 3.3. The 5 volt light is off. So let's go ahead and go into GPIO settings and turn that 5 volts on. And we'll set that to on, and you can see the light turned on. So here's that ultrasonic sensor, and again the header pins were already soldered on, so this is one of the first things you can do with the Flipper Zero. And make sure you have the latest firmware, because it appears that they've improved the way they calculate that echo time, and so it is a lot more accurate than it has been in the past. So a useful debugging tool is this I2C tools, and we can do a scan, and when we click that OK button, it does a scan, and you can see it keeps saying 0 peripherals found no matter how many times I say scan. So the issue is that our pull-up is not connected, and this device doesn't have a pull-up resistor, so we're going to go ahead and do that pull-up. And now this time when we say scan, you can see that it'll actually find the device, and the device is at address 040. So we're going to go ahead and head back over to that temperature app, load that up, and we'll go ahead and add our device, which is the HTU21D. So the HTU21D, and the address is correct, it's 40. So there we go, save that, and you can see the temperature and the humidity. Next up we have the D1 Mini. I flashed the firmware. I'm not sure if it came pre-flashed or not, but the flashing process is fairly straightforward. You're going to want to make sure you're using the Wi-Fi deauther V2 application. And then for me, I typically just head down to the reboot option and say reboot. And then once that boots back up, you're going to have an access point that you can connect your laptop to, and it'll show you the SSID and password. And once you've connected your laptop to that network, go to 192.168.4.1. You should see this warning message. Click on the accept, and then you should be able to see your devices and do scans and do attacks. So again, this experimenter board looks really impressive. I'm clearly going to need to do a few more videos to be able to walk through everything that's available on this board. So please subscribe to the channel, and we'll try to make videos looking at the ESP32, the NRF24, the NFC tags, the RFID key fob, the SPI protocol, the UART protocol, and wire up some of our own circuits. If there are specific areas of the Dolphin you'd like me to experiment with, please leave a comment below.